We look at our starting problem equals natural log of 1 minus cosine squared. We do this to see what we need to solve. This is our original equation. We find that the function is equals natural log of where equals 1 minus cosine squared. We do this to see how the parts fit together. This helps us know which math rule to use next. We plan to use the rule sine squared plus cosine squared equals 1 to change 1 minus cosine squared into sine squared. We do this to make the equation easier to work with. This is true math rule for sine and cosine. We write the new equation as equals natural log of sine squared. We do this to use our simpler version. We replaced 1 minus cosine squared with sine squared. We look at the rule where natural log of to the power of equals times natural log of. We do this to prepare for moving the small number. This is math rule for logarithms. We change the equation to equals 2 times natural log of sine. We do this to move the exponent out in front. The rule says we can move the power of 2 to the front as multiplier. We prepare to find dy divided by dx of 2 times natural log of sine. We do this to start finding the derivative. This tells us how the function changes. We apply the chain rule to get 2 times 1 divided by sine times the derivative of sine. We do this to solve the parts of the function one by one. The chain rule is used when one function is inside another function. We find that the derivative of sine is cosine. We do this to finish the last part of our multiplication. This is standard math rule for sine. We combine the parts to get 2 times 1 divided by sine times cosine. We do this to put all our pieces together. We are multiplying the 3 parts we found. We use the rule that cosine divided by sine equals cotangent. We do this to make the fraction look simpler. This is math rule for trigonometric functions. We simplify the expression to 2 times cotangent. We do this to reach the shortest answer. We replace the fraction with cotangent. The final answer is dy divided by dx equals 2 times cotangent. We do this to state our result clearly. This is the finished solution.